Farmers today are facing rising costs, volatile markets, and extreme weather. The A Better Way to Farm podcast digs into strategies to help you take control of farm inputs and maximize profit so your farm can thrive for generations. Remember to take advantage of our free resources at abetterwaytofarm.com. Now, from America's Heartland, here's your host.
Very excited for you to join us today for this really intriguing conversation that we are going to have. And I think that this is one of those topics that the time to study this is right now. Begin preparing for next year and maybe make some in-season corrections this year in regards to a lot of the things that we're going to cover today. My name is Andrew Moore. I've been with the A Better Way to Farm team now for 6 years. And so it's an honor to be your host today. And I'm going to have the great honor of having a good conversation here with my dear friend and one of the very best farmers I know. He's one of the most research-driven farmers I know. He's done just a boatload of on-farm research. Several weeks ago, months ago now, we've released a podcast in regards to root depth and soil pit data and things like that. And this individual is really the one on our team that kick-started that conversation. And he's done just an amazing job of being a good friend of the American farmer. And so I'd like to introduce my good friend, Mr. Curt Jacobs. Curt, how are you today?
I am good. And thank you for having me on today.
Very good. Very good. Well, we're going to dive right into our conversation here and what we're talking about. So let me just introduce this, Curt, and then I'll throw it your way. It's not a secret to those of us that follow us and follow our podcast that, you know, one of the things that we have been talking about now for decades is micronutrients and the need for micronutrients. It seems like the industry is finally catching up to some of the things that we've been saying for a very long time. And the fact that micronutrients for crop production, they're not micro because they're less important. They're just needed in smaller amounts. And so we've had a lot of good podcasts and content about the best way to solve micronutrient deficiencies and what that looks like. But today, we're going to really single out a topic. We're going to really dive into one specific area of micronutrients, and that is the area of the role of that micronutrients play in the biological functions in the soil. Okay? Not going to get into a lot of plant physiology today. Not going to get a lot into maybe the more straight line of this micronutrient means this for the plant, but the overall soil health and what do these micronutrients mean for that. So, Curt, tell us just generally what kick-started your research in this area for your farm and where did it take you?
Well, it all goes back to us starting working with A Better Way to Farm and been following Rod for I'm just going to say many years at this point, and listening to him talk, and I've heard him say the statement over and over again. In time, we're going to learn, in his opinion, that micronutrients play a big part in soil health and soil biology. So as we get to looking at our own soil tests, we're seeing things happening in the field. We came around to see that, you know, this truly is tied together. And so I started digging in deeper, doing some more research on this specific topic of how do micronutrients affect and help soil microbes. And it was kind of, I don't want to say I fell down a rabbit hole, but it got really intriguing as I kept researching further and further and finding more and more ties to exactly what we're already doing.
Excellent. So on your farm, you know, there's a handful of micronutrients that you are very consistently deficient in, okay? I'm going to throw a few of these out there, and then we're going to dig into them. Zinc is one of those. Manganese is one of those. Boron is one of those. And then we do see an occasional copper deficiency as well on your farm, and that's a common thing in the Midwest. So let's just start with the first one here, zinc. As you begin doing research here, what are some things that we found out about zinc?
Well, when we get into zinc and their role with the biology, we know it's heavily involved in protein synthesis, the metabolism of carbons, enzyme activations within the plant, zinc is playing a big role in helping us build bigger crops. And, we know when we're short a nutrient, any nutrient, it's going to cost us yields in the end. And, zinc helps those microbes process the carbon compounds more efficiently. And, if we're short on zinc, we're going to see things that are just going to be more sluggish. We're going to have some phosphorus issues. We might be seeing some weaker fungal activity happening. And, when we're not supporting the natural systems, we're probably relying on outside applications to basically put a Band-Aid on what's not happening that should be happening.
Absolutely. And so there was a lot there, and we can really dig into this. But a couple things to take away. One is fungal activity. We think about mycorrhizal fungi, right? And that's the big player when it comes to fungus. I was just in the field just a couple days ago in central Ohio, and we were looking at some roots and we determined that upon a lot of research and taking pictures and talking to some smart folks that we could detect mycorrhizal fungi already in the soil. And that was really, really exciting for that grower because he has been doing a lot of things on his farm to help build that up. He's reduced a lot of tillage and done cover crops and things like that. And so, and also this year he addressed zinc. That was one of his limiting factors. But one of the things that it ties directly to, like you said, is phosphorus. So zinc and phosphorus, it's really fun because these two are like two brothers that don't get along, right? And zinc is the little brother, okay, who is, the scrawny kid, and phosphorus is the big brother, and he always beats up on zinc. We have said over and over and over again, Midwest Labs has verified this, other people have verified this, that when you have a P1 level of 25 or greater on the parts per million, or a P2 level of 50 or greater, you're going to want to add a little bit of zinc in furrow because that's going to tie that up. Interesting. So obviously it goes to show that there's an antagonistic effect, okay, between the two. And when I say that, I mean phosphorus ties zinc up is really what I mean by that. But then we see the two actually can work together, okay? It's kind of like me and my big brother. My big brother was a lot bigger than me. He was 5 years older than me. And I was that little mouthy kid, and I always was right and smarter than him and better looking than him and everything. And he always beat up on me. But sometimes we actually got along. And it's kind of the same way. And where this really shines is in fungal production, okay? Obviously, mycorrhizal fungi is the number one thing that's going to enhance your phosphorus uptake in your root system. And zinc is one of those things that helps to build that fungi, all right? And so this is a great situation here where those two can work together. So I want to move on to manganese. Anything else on zinc here, Curt?
No, I don't want to get too deep in any of these because we kind of want to keep moving and covering these. But I do want to say before we go any further, just because we're talking about specific micronutrients today, this is not an open book for somebody to say, hey, there's a problem I have, there's a problem I see in my fields. If that's the nutrient that's going to help me fix my problem, I need to go spread some. We're absolutely not advocating for that today. So before you do anything, reach out if you're not already working with us, and we can help you out with some testing and some diagnostics to figure out exactly what it is that you truly need in your specific crop and field situations.
No doubt. Soil and tissue testing will always be king here. Good point there. Now, moving on to manganese. And I will say, as I read through this mountain of research that you compiled, manganese was one of the biggest things that we just completely blew my mind as to all the roles that it had. So tell us a little bit about what you discovered with manganese here.
Manganese, as we keep digging into this, and like I said earlier, it kind of feels like we're going down a little bit of a rabbit hole, but manganese just keeps coming back and being tied to just about everything that we've got going on in the field, from decomposition to fungal activity to, we start looking at ratios that can get out of whack with iron and manganese, and we start seeing all kinds of problems that can come up with it. And we even are dealing with specific herbicides that are tying it up. And just, even though we were always told that one specific product hits the ground, it's neutralized, it's done, no big deal, it's not going to cause any problems, I still come back and say, there's got to be a connection here, because when we use that product, we still see a microbial imbalance because that manganese becomes tied up or impaired. That's causing us to have slower stock breakdowns. That's causing us to have more stock residue carryovers. It just keeps going on and on and on. And, this is another one of those things that we keep calling a low-hanging fruit item. And it's not hard to fix. It's not hard to do. Once again, we go back to the testing. But the microbes are using manganese and lignin breakdown for stock decomposition. Manganese is big on our early plant growth, on our germination side, so we want to make sure we've got that taken care of by the tests early on. I'm trying to dig back into some more of my other notes on manganese, because I know I have it sitting here. A lot to sort through here.
Curt, I tell you, while you're looking through some of that, I want to sit on one of these things here for manganese, okay? This is the part that really blew me away. We talk about stock digestion, all right, and decomposition of stalks in the fall. We often recommend a stock digester. It's got a little bit of nitrogen, sulfur, help get that nitrogen to carbon to sulfur ratio imbalance, and a couple of other ingredients to help stimulate the biology. But frankly, what we're learning here is this, and that is that a manganese in the plant has a direct correlation to how well these stalks break down, okay? And I never would have dreamt that a micronutrient played such a big role in that. I always thought, we always talk about carbon, nitrogen, and sulfur for this breakdown process. But one of the things I want to come back to is this, all right? We can do research. Universities can do research. And this is not a blanket anti-educational statement here, okay? Some people really are not pro-universities and don't believe anything they say. That is not what we're talking about. But I often find that we, as a society, and that universities, we're really good at diagnosing problems, but we're not always good at solving problems, okay? And here is a prime example. What actually makes the stock to digest and to decompose? It's the micronutrient in the plant, okay? In the leaf tissue, in the stalk tissue, all right? A granule pellet of manganese or whatever your source is in the middle of the row or in the soil doesn't really do much for you here, okay? Just like the state that I'm from that grows a lot of rice, all the universities talk about how you got to have zinc for rice production, and then they recommend throwing 20 pounds of zinc sulfate out there, dry broadcast. That is not going to solve your zinc problem, okay? And I'm just using this as an example here, and it's a great opportunity to talk about why we often talk about placement so much. And that's the conversation that a lot of people don't want to have, is this is a prime example of how placement really, really matters, okay? Because it directly impacts the ability for your soil to break down that plant residue, number one. But number two, I dare say this, in the case of all of these micronutrients, in order for Mike, that's what Greg Sauter calls the microbiology, in order for Mike to do what Mike does best, guess what? These micronutrients, and I dare say all of our fertilizer, is going to be best used in a biological form, not necessarily in a mineral form, okay? And so the most direct, straight line to get these micronutrients to a biologically usable form in the soil is that decomposition process going from plant residue to actively being able to be used in the soil. And so I know I kind of just threw a lot out there, but it's just something to think about. You say you're talking all this lignin breakdown and protein synthesis and decomposition, but what do I practically do with this information? And that's why we're saying don't just go broadcast something out there. Give a lot of thought on how we address this. And so it's not just because it's the best uptake for the plant, but it really is the best situation for the soil when we row place these or foliar feed these micronutrients. Curt, what else on manganese have you found here?
So we also know manganese gets really interesting in the fact that it helps drive oxidation reactions that help support the beneficial microbes. A lot of plant pathogens tend to thrive and survive in low oxygen environments. So anything we can do to help increase that oxidation, that oxygen in the environment, in the root zone, within the plant, we can definitely help those microbes and support that disease suppression. Manganese deficient plants typically will have weaker cell walls and lower natural disease resistance. So that's where some of the problems come in. Actually, manganese is not fungicide. In a way, from a biochemical standpoint, it's helping out in that plant defense.
Excellent. So I assume, especially in a year like this year, when we had a lot of cold and a lot of wet, emphasis on a lot of wet and a lot of, we'll call it oxygen-deprived soil. That's what wet conditions mean, that this was one of those things that you wanted to have in the tank mix and the in-furrow, assuming you were deficient in manganese. So that's a huge deal. Let's go ahead and move on, Curt, to copper. Tell us what you found out with copper.
Copper is one of the ones I'm just going to really kind of skim over, only for the fact that a lot of this, it's not saying it's not important, but we know, copper is somewhat of a anti-micro or antifungal, so it leads to more disease suppression. Copper does help with nitrogen cycling, so it's beneficial all the way around. A lot of fungicides, if you keep digging in, you're going to find a lot of them do have copper in them. So, it helps balance bacterial and fungal populations when used judiciously.
So copper is one of those, if you have a deficiency, you want to address it, but you also don't want to overdo it.
Absolutely.
Very good. And then moving on, what about iron? Iron's one we don't really talk about a lot, but it is important. It's not something you're deficient in. It's not something
No.
I'm deficient in, but certainly we have some listeners that do have iron issues, especially out west. So Curt, what's our take here?
Iron really helps drive some electron transport, which some people might be saying, well, what? But everything that happens in anything that's biologically alive, it's transfer of energy, transfer of electrons. So iron is definitely important in that aspect. It does help out with some respiration, some plant energy production, and iron does play a role in nitrogen fixation. So we want to make sure we're keeping that also in an adequate zone. Like for myself, I'm excessive in iron, so manganese is one of those things that we need a lot of, and iron we definitely don't ever see a call for in any of our testing. But without it, like I said, you might have some nitrogen fixation, meaning slowed down, energy transfers weaken or slow, and then when we slow up everything else, we slow down the microbial activity as well. So that's one of those things we do want to keep an eye on. We want to take a look at, but at least for my part of the area, of the corn growing area, it's not something that we're needing to feed. So.
Okay. Now here's one that I know is a big one for you and for me, and I would dare say for 95+% of all growers out there, no matter what crop you're growing. we see this very deficient across the board, and that is boron. Obviously, we from the 12 nutrients of Christmas and all the content that we put out on these nutrients, boron is huge for all the reproductive aspects of the plant, huge for moving nitrogen inside the plant. But what did you find for the biological aspect of boron?
Boron gets really interesting because it is another one of those macros that is so tied to so many functions within the plant. Microbial signaling, as far as we need boron to get our mycorrhiza up and going, and we're, in a lot of cases we're recommending some boron early to help with that. Boron is big on cell wall integrity, sugar transportation, and when we're talking about sugar transportation, we're also needing that root exudation so that we can get those sugars back into the soil, back to the microbes, and keep the whole cycle going. So, it leads to the healthy root exudates. It indirectly is fueling the biology. And, it might be one of those things where, in general, we could say maybe it might be an interesting way of looking at it is the micronutrients that are needed for biology is similar to the spark plugs that are needed to get our trucks down the road. If we're short or we're fouled out, everything's going to go a whole lot slower. So, boron's huge. Rod hits on it time and time again. Like you said, it's been in the 12 days of nutrients. I think, honestly, we could probably do enough research here that we could do 6 to 8 days of nutrients for microbes. Just as we keep digging into this, there's a ton of information out there. We're trying to just skim the top of it to get you a rough idea of what's going on. But boron's huge all the way through, from the plant to the microbes to everything that we've got going on in the field.
Absolutely. And so huge deal there. And I do want to reemphasize that mycorrhizal. You bring that up. That's one thing that we've been looking at now for a couple of years, is the fact that boron is directly related to that. And as we found out, zinc is as well. And so that's a huge deal there. But that's something that's ginormous. And then that sugar movement, as well is a big deal for boron and moving those sugars. Ultimately, when you're growing corn, you're growing sugar. You're raising sugar. That's what helps fill that kernel. That's what drives the whole process. Anyways, that's just sort of an overview, and I want to give Curt, some recognition here, because all this information, we have found multiple source documents on university research from Europe, research from here in the United States, NRCS research, a lot of good stuff here supporting this information. And we are starting to see, Rod's been talking about this now for 2 years, but we are starting to see a lot more research come out in just how these micronutrients play a role in soil biology. And so this is just the beginning. Probably for our more nerdy listener. Now, that's not an insult. That's a true deal. The grower that wants to really learn more and manage on a really in-depth level, this is for you. And so, Curt, just one last parting question here. I guess, what's your big takeaway, or what's your next big thought on where this could go? Take away from this research, and then what direction you think we're headed here with all of this information?
Well, I think this is just the beginning, and as we see carbon programs going on and we see different things happening, all of this is going to be tied together to soil health, plant health, and just doing better and getting to where we're producing more efficiently. I mean, if carbon is the fuel for the soil biology, then the micronutrients are the spark plugs, the injectors, the wiring harnesses to make everything go. So without them, we don't want our biology slowing down. Nutrient cycling is going to slow. Nitrogen fixation is going to suffer. Soil health declines are probably going to be happening. And I'm not diagnosing anything. And like I said earlier, I'm not telling anybody these are some things you got to just go throughout to fix. Let's do some testing. Let's do it right. Let's do it judiciously. And I think we're on the horizon of learning a lot of information. So past, we could be looking at the just the lower peak of the mountain ridge of where this thing can go and what it can actually do when managed and implemented correctly on anybody's farm.
Well, Curt, once again, thank you for all your work on this, and thank you for being a leading member of our team and all the research that's going on. And I just want to encourage everyone to take a look at this. If you haven't listened to the 12 Nutrients of Christmas, we do that podcast every year. Rod really digs deep into the functions of these nutrients, both in the soil and in the plant, and how to manage these things. He goes from scientific to practical. And so look that up on the podcast. And with that, thank you everybody for listening, and we hope you're having a better day.